Hello YouTube! In this video we're going to look at our battery monitor.
If you're running an off-grid power system, and by that I mean any power system that isn't connected to a grid or a municipal power supply, mains power if you will, you need to know that your system is healthy. So have you got food that's fresh in the fridge? Have you got the lights on? And can you put the heating on? On a boat, of course, you also need to make sure that your safety systems work. So have you got enough power to pump use the bilge pumps in the event of water ingress? Have you got enough power to make sure that you can send a radio message in the event of an emergency, and that you've got enough to use your navigation systems? And in order to do that, you need to know how your batteries are performing. So is it charging correctly? Is it retaining its charge? And how much current are you using? And particularly, are there any parasitic loads that are draining your batteries that you didn't know about?
In many ways, it's these pesky little power drains that we forget about that cause the most grief in today's off-grid systems. So many devices we use can't be turned off. When you press the off button, you're really only putting them in a state of standby. Anything connected to the Wi-Fi network, for example, will remain connected with a stay alive signal to make sure when you turn the device back on, it doesn't spend an age negotiating an IP address with your router. Many devices like your kitchen microwave has an onboard clock, and that uses power. Mains outlets with USB sockets use buck regulators that draw power all the time when they're not being used.
At home, that might add up to just a few extra pounds on your monthly bill, but here it could mean waking up in the morning and not being able to put the heating on.
It's very clearly essential then that we need some form of battery monitoring. There is plenty of choice for the consumer and over a very wide range of price points. But where there's choice, there's also confusion. So where do we start?
With lead acid batteries, the voltage drop is relatively linear as the battery discharges. So with nothing more than a decent voltmeter, you can see at a glance what's happening with your power system.
If you wanted more detailed information, you could use something like a Merlin smart gauge, a device that I've relied on to provide primary battery information on my last 2 boats. It was excellent at telling me what the state of my electrical system was, but the one thing it couldn't do was tell me how much power I was using, and particularly help me find those parasitic loads I was talking about. For that, I need to measure more than just the voltage. I also need some method of measuring current. There are 2 principal methods of measuring current. One uses a device called a shunt. A shunt is installed in line with the main circuit, allowing a meter to be connected which accurately measures the current passing through the system. All you'll need is to select one with enough capacity to easily be able to handle the highest loads you'll ever draw. The one I've installed is rated at 500 amps, and my main fuse is 450 amps. So hopefully the fuse will blow before the shunt melts.
So we've talked about using a shunt to measure the current, but there is another way to measure current, and that is using one of these, an amp clamp.
When a current flows, it creates a circular magnetic field around the wire. The amp clamp detects the strength of that magnetic field. To be technically more accurate, it's called a Hall effect sensor. But effectively, you just need to wrap one around your primary power cable and you should be able to measure the current that you're using.
In its simplest form, we can just use the amp clamp by literally clamping the ammeter on top of the cable.
If we start up the microwave to draw a decent load, we can see the amp clamp climbs up to 113 amps. Let's compare what we're seeing at the meter that uses the shunt to measure.
So that's 110 amps, but we've got some solar going in.
So you could use a shunt or you could use an amp clamp. Obviously the shunt, you physically have to install it and you have to make sure that none of your wiring bypasses the shunt. If you're using an amp clamp, you've got to put the clamp in the right place so that it's not affected by other magnetic influences. But in terms of the results that you get, it's negligible. You don't need to know the difference in milliamps between the 2 systems. It's not really relevant. What you want to know is a rough idea. I mean, putting a microwave on and drawing 113 amps, that's a big deal. Also, getting down to the nitty-gritty of turning everything off so that you can get rid of all that quiescent current. That's what you're really looking for. But ultimately, what you want to know is, are the batteries performing okay, and do you have a balanced power network? And if the answer is yes, it doesn't really matter what method of measurement you're using.
So let's take a little look at how we actually use this to keep track of our power drain. Currently, I've just come back to the boat after a couple of days with all the electrics switched off. So there's been no power drain, and it's been sunny. So as expected, we've come to the boat, and as you can see, what we've got here is 100%, which is what we'd hope for. So the batteries are fully charged. We can tell that the 14.4 is the charge voltage, which is correct, and it's still putting a little bit in, which is why the screen's glowing. Now what I'm going to do, I'm going to disconnect the solar panel, and we'll see what the current draw is. Bear in mind, at the moment there's nothing plugged in apart from the controller, the solar controller itself, which obviously does draw power, and this, which does draw power. Everything else is switched off. Okay, so the next thing to do then, we've got 0.06 amps going out. Now I'm going to go and turn the power on. Right, so that's the fridge on, and obviously the fridge is, at the moment, it's not cold. The compressor's going to be on full for a while, so that's giving us 3 amps there, plus the 0.6 that we had for the controller and the battery monitor. Now I'm going to go and turn the inverter on. So altogether, almost 5 amps, 70 watts. And really, at the moment, apart from the fridge, there's not actually anything running. Now, if we turn the microwave on, obviously we're going to see a huge, great surge. And off. Let's plug it back in again. Make sure we've got power while the sun is shining.
Obviously we can get the solar information off the solar charge controller, but that just tells you what solar power is going in. The battery monitor shows us the full state of the entire system, and importantly, whether there's a net loss or gain.
So that's the 5.2 amps going in, 5.1 amp, 5.2. Quickly compare that 5.2 going in with the 0.96 going out. So we're currently using about 6 amps. So you can see in real time you drawing current, but only just. And now the sun's coming out and you see that it's started to change. That's literally the sun coming out from behind a cloud. And if it comes out from behind a cloud long enough, we might see that raise. Look at 1.2 now. Now we're hitting 3 amps. There's no change on the amount of current that we're drawing, by the way. I've not turned anything on. 4.6.
So this device is the Renogy 500 amp battery monitor with shunt sampler. We have talked about how to install the shunt, basically in line with the negative terminal of the battery. You do have to run a positive cable to the battery to power the monitor, and you also get this multi-pin plug that connects the display screen. Once the shunt is in, you have to configure the monitor. Just press the OK button for 3 seconds and it goes into setup mode. Here you can enter the capacity of your battery bank and the full charge voltage of your battery. There's also a low voltage alarm, a power off threshold which effectively turns the monitor off completely, and a low capacity alarm which can give you an alarm at say 30% left to remind you to start turning stuff off before you run out of power completely.
Well, there we are. That's the battery monitor. That's how we use it. It's an important piece of equipment, and I'd recommend you get one if you've got any kind of battery-powered off-grid system. I hope you enjoyed the video. Please like and subscribe, and thanks for watching.